We propose HumanRef, a novel framework for 3D clothed human generation from a single reference image. Given an input image, we first utilize existing estimators to derive the corresponding text caption, skinned SMPLX body, front and back normal maps, and silhouette. Subsequently, we initialize a neural SDF network with the estimated SMPLX body and initiate an optimization-based generation process. During the optimization, we render the SDF network in front, back, and other random views. In the front view, we employ the input image and its silhouette to construct a reconstruction loss to ensure appearance consistency between the generated 3D human and input image. Besides, to guide the model to generate reasonable human geometry, we calculate a L2 form normal loss between the rendered and estimated normal maps in the front and back views. Most importantly, for regions invisible to the input, we propose a Ref-SDS method to distill realistic textures consistent with the input image from a pre-trained diffusion model. To further enhance the texture details, we implement a multi-step denoising process based on our region-aware reference-guided U-net, and calculate a perceptual loss between the rendered and enhanced images. To constrain the pose of the generated human, we additionally introduce a L1 form SDF loss between the predicted signed distance value and that queried from SMPLX body mesh. By employing these strategies, our HumanRef could generate a sharp and realistic 3D clothed human aligned with the input image. To evaluate the performance of our HumanRef on 3D clothed human generation, we compare our method with 3 state-of-the-art baseline methods, including PIFU, PAMIR, and a concurrent work, TEC. Here, PIFU and PAMIR are 2 learning-based methods that acquire the ability to infer the geometry and texture of a 3D clothed human from input images after being training on a large number of scanned human datasets. Their performance thus is limited by the training data and model design, struggling to infer detailed textures and fine geometry from a single image, particularly in areas invisible to the input. By contrast, TEC can generate detailed textures in unseen areas due to SDS-based text-guided optimization and pre-trained diffusion model priors. To mitigate oversaturation in SDS-based generation and enhance realism, TEC employs strategies to minimize SDS denoising diversity, including precise text inference via a question-answering algorithm, textural invention, and diffusion model fine-tuning. Nonetheless, TEC struggles to achieve texture consistency with the input image due to the lack of image-level guidance in SDS denoising. As shown in this man example, TEC generates a realistic blue T-shirt texture on the back, but there is still a noticeable difference from the dark blue texture in the input image. In contrast, our method, HumanRef, generates realistic and detail-rich textures that are more consistent with the input image. For geometry generation, although lacking a specialized design like TEC, our method produces reasonable and complete 3D human structures, while TEC suffers from issues like geometric breakage and stretching in the generated human feet. Moreover, in the woman example, our method successfully generates realistic view-consistent texture and geometry for humans with complex clothing textures that TEC fails to infer. Here are more results of our method. Thanks for your watching.